Let's get started. Okay. So as I said, we'll take a look at a few of the SQL concepts before we proceed to Power BI. And it's more like a refresher for you all, the ones who completed SQL. But for the ones who directly, who have joined directly for Power BI, this will help you to understand the SQL concepts first, and then we'll move on to Power BI. Okay. Today and tomorrow, let's spend some time on SQL only. Okay. Fine then. So why SQL is needed? So a simple example would be, let's say yesterday I was in project session. Of course, it's not for Power BI people, but for the Excel ones, we completed a project, right? Somewhere around we got 8,000 records data there in that project, right? So before starting any project, what is that we wanted? Some data, right? For any report creation or a dashboard creation, what is needed? Some data. And this data can be stored in Excel files, CSV files, PDF files, and different places, different locations, right? It could be there on a shared drive. It could be there on a SharePoint. It depends on the organization. So once we have this data, after that, we can move on to the report creation, right? But coming to this data, usually in a mid-scale or a big-scale company, we have this data in the databases, right? We don't see this data in, Excel files always, because Excel file has a limitation. What is that limitation? The size limitation, right? So every Excel sheet can contain only what? How much data? 10 lakh rows, 10 lakh, 1 million rows. But when it comes to the real-time data sets, this may go to 2 million, 3 million, 10 million, 20 million also. Depends on the company. So if that is the case, then Excel is not the right tool to use to store the data always. Excel is a great tool, no doubt about it. You can create so many dashboards, reports, and things like that. But when it comes to the data storage, Excel is not the right tool. But usually what happens, all the small and mid-scale companies also, they prefer Excel. Of course, large-scale companies also, they prefer Excel for the data reporting, not for the data storage. Okay. So what we need to have is to store millions of records, we need a database table. There are different types of database tables. I mean, the databases are available in the market. Something like SQL Server databases, MySQL databases, Oracle databases, SAP HANA, or you name anything, any database, right? So you have so many databases available. But one thing is that if you want to do the data retrieval from the database, you need a common language, right? To talk to the database server and to get the required amount of data, right? Probably most of you are here working with Excel a lot, doing, different calculations on the data, conditional formatting, building different templates using Excel. You may be doing that already. But the thing is, to create any kind of report, we need what? We need the data. And this data is located inside the databases. So we need a language which can talk to the database server, and it can help us to do the data retrieval. You may be using Power BI, you may be using Excel or any other reporting tool for that matter. But as long as any RDBMS is concerned, it understands a language called SQL. Okay. And we go there, we write a query. Usually all these queries for a reporting analyst, from the reporting analyst or a data analyst standpoint, we write select queries. Okay, there are different types of SQL queries available, but we only write select queries. Okay. So queries and all will be covered in detail in our SQL sessions, but whatever is needed to build a report in Power BI, I'll cover that. Okay. So the SQL concepts. that are connected to Power BI. I'll cover that those concepts in these sessions. Okay. But the select queries and all will take some time because there are so many concepts, right? The ones who completed SQL, you understand. Select so and so from so and so table, where clause, having clause, group by, order by, using aggregation, non-aggregation. So many things are there. But yeah, someone who joined directly Power BI, you don't need to worry about those things at this point. But there are a few points that you definitely need to understand from SQL standpoint. So I'll cover that. Fine then. So we need some data. Data is here, and we want to build a report using Power BI. So we can use SQL as a language to connect there and can get the required amount of data. That is a plan. Okay. Fine then. So any reporting, any data and analytics profiles, they look like this only. So we use a reporting application, and with the help of SQL, we interact with the databases and we create the reports. It's as simple as that, right? Hope everyone is clear about this. And we also need to understand there are two types of systems. Once you join an organization, you will also hear these two types of systems. They are OLTPs and OLAPs, okay? So let's try to understand what is OLAP and what is OLTP. OLTP is online transaction processing. Okay, online transaction processing. And as the name says, online transaction. It's meant for transactions. So what could be a transaction? What could be a transaction? It's just not only about inserting any kind of modification. You can consider that as one transaction. So basically, you may insert something, you may update something, or you may delete something. All these things are, each thing is one transaction, right? We also do a lot of transactions every day. So can you name a few of the transactions that we do every day? Right. So something like a UPI transaction you can do. Just not only that, let's say if you post something on Facebook, it's also one entry for it. It's like one transaction recorded inside. The transactions not necessarily, financial transactions only. It could be any kind of a transaction. That thing, but you interact with the database, you insert, update, delete something. It's recorded as one transaction, right? So there is a dedicated system available for this, which is OLTP, Online Transaction Processing System. So this is basically to manage the database modifications. Okay, this particular system. And the focus of this system is just limited to insert, update, delete. Simple. Inserting data, updating data, deleting data. So I always say this, the best example for OLTP is the billing counters you see. You go for any shopping and there you see billing counters, and all those systems are connected to OLTP servers only. Okay. So what is this OLTP? This basically helps us to insert, update, delete the data. So if you buy something in a shop, okay, they generate a bill, right? Nothing but one transaction is inserted in their database table. Is one transaction, right? So inserting a new transaction, update, something like you want to get your mobile number updated. Yeah. So profile remains same, the record remains same, but mobile number to be updated, right? Delete. Let's say you have two addresses there. One of those addresses you want to get deleted, right? Inserting, updating, deleting. So these kind of things are commonly, are usually done in the OLT. Okay. So ATM is also another best example of OLTP only. So this also does what? Insert, update, delete kind of things only, right? So I think I asked this question to the SQL people, but let me ask you this. When you withdraw money from your account, from ATM, what kind of a transaction is it? Is it an insert transaction, update transaction, or delete transaction? Is it insert, update, delete? It's insert only. Don't think it is update, okay? Your balance doesn't get simply updated. No. There will be a new transaction recorded stating that there is a cash withdrawal from so-and-so ATM machine, so-and-so time. This is the amount and the balance is this. Nothing but one new transaction will be inserted into the table. It's not an update. Okay. Fine then. So ATM also a best example of OLTP. What is the date? Coming to the data, OLTP and its transactions are original source of data. Nothing but that is where the actual transaction takes place for the first time. Okay, that's where the data is recorded for the first time. So the data can come from different, locations in an ATM. If you take an ATM example or a billing counter example, so all these machines are connected to one server, and all these records are getting stored in one table. You may access one ATM in one location, and the others may access some other ATM, some other location, but all this data is getting processed and stored into one database. There could be multiple also. It depends on the infra, how they planned. Okay. So it is original source of data. Why do we call this as original source of data? Because that is when the very first thing gets recorded inside the system, right? If you go to ATM and you do something, that is where the actual transaction takes place, and that's where it's stored. And that record can be moved into other systems also. We'll talk about OLAP later. Okay. This is the original source of data, and OLTP has shorter transactions. Why? Because to perform this insert, update, delete, it doesn't take much time. Even if you take a billing counter example, what happens there? How much time would it take if no one is there? Hardly need 5 minutes, right? So why it takes only less time? Because it is only inserting, updating, deleting. You are not writing any complex query, right? Why? Because when you want to do a transaction, what is it? It's simply like, scan the code, right? And enter the quantity, generate the bill. That's it, done. But in OLAP, it works in a little different way. We'll talk about that. And as these are short transactions, the time it takes, very less, comparatively less. Here we write only simpler queries. Why? Because only insert, update, delete queries only, right? These are very simple. Okay. And coming to the normalization, I'll explain these 2 points in the next example. Let's leave these 2 points, normalization and integrity. Coming to OLAP, it's a data retrieving and data analysis system. You see that we have a dedicated system to do the data retrieval. You may get a question here. You are saying that the data is actually getting recorded here, right? So what is the point again, having one more system to do the data retrieval? Anyways, the data is there in the OLTP, right? Can't I do the directly, data retrieval from the OLTP? Simple thing. There are 2 systems. One system is taking care of inserting, updating, deleting the data. The other system is taking care of only data analysis and data retrieval. Why do we need to have 2 systems? I can ask the first system only because the data is getting recorded there. Can't I ask the first system, okay, get me this data? Why I need to depend on the second system to do the data retrieval? So the best example would be, at the same point in time, you cannot do both, right? Especially handling a good number of customers. OLTP's job is to do the transactions, right? So let's take an example of Amazon. Amazon has so many customers. Everyone maybe, placing so many orders in every minute. So this system is already busy in serving the customers. On top of that, as a reporting analyst, I'll put one more request on the system saying that, okay, I want last 6 months data. That means the same system is now responsible serving thousands of customers at the same time. Plus my request as a data analyst, please give me this last 6 months data. There may be like a good million records of data. And this system may be, this may become very, very busy handling both of them. One is the data retrieval. The other one is the data inserting, updating, deleting process. Okay. So to avoid these kind of issues, what we usually see is that 2 types of systems. One system is to interact with your customers. Other system is to do only the data retrieval and data analysis. Okay. Extract the data for analyzing that helps in decision making. Yes. What is the focus of OLAP? We extract the data, right? That is where we learn the select queries in SQL. Here we go. It doesn't have an original source of data. The data that comes from the different OLTPs only. Different OLTP databases become the source of the data, for OLAP. That means the OLTP data only will be copied or, depends. We will be cloned, you can say, or will be loaded, you can say, into OLAP. Okay. Because this is the original source of data, right? The same data will be loaded into OLAP. But after doing the required data transformations, that is where we have a profile or a job role called, you would have heard this, ETL developer. You know, this ETL developer's job is to get the data from different OLTPs. That is where the data, actual data, original data is stored. From there, they extract the data, transform the data into required shape, and then load the data into OLAP. That's what they do, right? So for that, they build the data pipelines. You know, there are like so many things. Okay, they do the programming. They have different tools to get the data from the different OLTPs into one OLAP. So the role is called ETL developer. You would have heard this ETL. We also do ETL, but that ETL is a reporting level ETL. So that is different. This is database level ETL. Okay. So OLAP is usually used by data analysts or reporting analysts. Okay. OLAP has long transactions. Why? Because the queries, what we write, they are not simple insert, update, delete queries. They are complex decision-making queries. This could be like this. You want to get the last 6 months data from a particular region where the transaction value is more than 10,000 and grouped by so-and-so product, right? And that product quantity should be more than 50. You see that? All those different combinations and conditions when I'm including, obviously the system will take more time to understand the query and process according to the query and return the output. So these things, they take long time. Okay. And the processing time, yeah, obviously comparatively more, that, right? Simple. If you want to insert one record, you simply, the code would be inserted to the table, values are so and so, done. Execute the code and you will get that record inserted. But when you want to write a query to do, something for decision making, okay, then you will write very complex conditions there, aggregations there, right? With so many having clauses, group by, where, subqueries, and things like that, joins, the other thing. So when you write a complex query, definitely takes more time to process that request, right? It's not like a single transaction. So you get so much of data. As we write complex queries, no surprise if it takes more time, right? You got some idea about the two systems used in the real time? Now you tell me, as a reporting analyst or a data analyst, which system access do we get? OLAP or OLTP? OLAP.
Deep.
OLAP. OLAP. Why? Because this is meant for what? We retrieve the data for the analysis purpose, right? That helps us in decision making. So that's the reason reporting analysts and all, we all get OLAP access. Okay. This is where we also hear about a data warehouse. Data warehouse. What is data warehouse? Data warehouse is a place, it's a central repository of all the data that we get from the different OLTPs, right? So if we have a central repository, then it is very easy to build any kind of a report on that, right? If the data is located in individual databases, and if you want to see a consolidated report, may not be possible. But if all these individual databases data is collected into one central repository, like a data warehouse, I can easily connect to the data warehouse and I can create the reports and do the required analysis. So as a data analyst, we usually connect to the data warehouses only, not to the live systems. There are instances where you will have to work with the live systems that are managed by OLTP, but very few kind of roles they require you to connect to the live systems. I can give my example. When I was with the contact center, which is nothing but the call center analytics, you need to connect it to the live system only. See the, what do we say? The regular reporting, like daily reports, weekly reports, monthly reports, all of them are like common in every reporting role. But along with that, you also need to do live reporting in few of the profiles. Contact center kind of a thing or a call center kind of a thing. You cannot report the data always, on the next day. You need to do the live reporting also. Means the best example would be when you give a call to the any of the call centers, they ask you to choose the IVR, right? Yes, IVR options like you select one for this, you select two for this, and if you are looking for a support for this particular thing, select five. That means there are different agents working on different queues. If one queue load is more, it is showing 50 customers are waiting in this queue. Then what we usually do is that we show that on the live basis. Okay, there are 50 customers waiting in this queue. So you need to dynamically move the resources from other idle, what is that, queues to this busy queue, right? We just shift nothing but, we change the roles. I mean, of course, the workforce management people, they do that. But we show those numbers. Okay, in this particular queue, there are so many people waiting and the average wait time is increasing. Okay, so average wait time, average handling time, different metrics are there in the call center analytics. Okay, so these kind of things require a live database connectivity. There are a few roles you need to do the live reporting also. Our reports get refreshed for every 10 minutes. That's how we schedule the entire thing. Every 10 minutes, it sees the data. Okay, how is it? Is it like, okay, which queue has more number of, what is that, customers, right? But most of the times, as a reporting analyst, we work with OLAPs only. Okay. I told you, right? What is the process that gets us the data from different OLTPs to OLAP? What is that process called? Discuss, right? One process that helps us getting the data from OLTP to OLAP. ETL process, right? Perfect. Yeah, ETL. Extract, transform, load. That, most of the businesses, the process is like this. Once the ETL is done, we get an email confirmation from the data warehousing team or the data engineering team saying that now the data warehouse has been updated with the most latest data. You can run your reports. Usually we wait until that email comes to us. Why should we wait for it? What is this ETL process? What do they do? Right. They get the data from different OLTPs and they load it into our data warehouse, you can say, right? Okay. Now you tell me, why do we need to wait for their email? Why can't we simply run our reports before that email comes? Let me explain this way. Let's say if the ETL is not done, they do every midnight, okay? After 12 o'clock, they do the ETL. Nothing but between 12 to 1 midnight, they get all the OLTP data till that, day, 12 o'clock. Yesterday is 12 o'clock. Up to that, they get all the data, they load it into data warehouse. Usually the data warehouses, you see a lag of 1 day. Why? Because if you are running a report today, you will be able to report only yesterday's numbers, not the live numbers, because live feed is not happening there, right? So if that is the case, yesterday's data would have been updated. Let's take yesterday's example, okay? Till midnight, Sunday midnight, okay? All the data, nothing but Saturday midnight to Sunday midnight, all the data will be copied and loaded into, I mean, extracted and transformed, loaded into our data warehouse. So when today early hours, maybe 1 o'clock, 2 o'clock, between that time. And we need an email stating that, okay, so the ETL activity has been successfully completed and now the data warehouse is up to date. Then when I run the report, I can get the data till yesterday, which is Sunday. If that is not there, if that email is not there, that means my data warehouse is still with Saturday's data only. You see that every day they do that ETL activity. And once the ETL activity is done, as a reporting analyst, I need to run my reports. If I do it before the ETL activity, that means my data warehouse still contains what? Day before yesterday's data. If it is a daily ETL activity is happening in that company, it's not necessary that the ETL needs to be done daily. There are companies basis on their business, requirements and all, they may do a weekly ETL. Possible. The last project I was working with, it was like a more like an ETL, done on a weekly basis. Sometimes they used to do on-demand ETL also, but usually it's a Monday early hours. They used to do the ETL because it's more like weekly reporting only. They don't want a daily report. If it is daily report, then the ETL should also be done daily, right? It depends on the type of the business and a few of the businesses. I told you, right? The call center kind of a thing, that you cannot wait for one day to manage your workforce. So that needs to be done on live basis. So different things are there. So remember, we need to wait for the ETL confirmation before we run the reports. But otherwise, if you run the reports before the email confirmation from the ETL team, that means you are dealing with day before data, right? We'll talk about what is data normalization and integrity also. So up to this point, everyone clear? The two types of systems. Okay, tell me which type of system as a data analyst we use. Well, okay. OLAP. So coming to normalization, let me show you this example. Someone who is new to Power BI or directly, what do we say? Who joined Power BI directly without SQL. Let me ask this question to you, or maybe others also can answer this. Looking at this data, can I create what is the total salary paid by the job? Total salary paid by the job. Is it possible? Total salary paid by the job. Do we have the salary column, job column here? Yes? Perfect. So if you have the salary column and job column, can we create total salary paid by the job using this? Yes, possible, right? Because both the columns are there. Yeah, both the columns are there. So you can easily create a pivot table if needed. So how do we do that? Insert pivot table, and yesterday, the ones who joined Excel sessions, you know this. So you just select the data, go insert, pivot table. What is it you want to show? You want to show the salary, right, and the job. It's showing the count, but you can just change the value field settings to, yeah, this is each and every job and the total salary we are paying. And what is the average salary paid? Yeah, just change it to the average, right? This is how we do it, right, in Excel. You can use a pivot table and you can quickly analyze it. So can I do what is the total salary paid by the department name? Is it possible? Possible, right? Okay. Can I do what is the average salary paid by the gender? Is it possible? Right. In all my questions, you are finding the answers in the same data set for all my questions, right? But here's the point. Take a look at this. Look at this data. Can I get total salary paid by the job using this data? Yes, no. Paid by the job. I want to see managers how much paid, testers how much paid. No. Why it is not possible? Correct. In this table, we don't have the job name like manager, tester. These kind of things are not present in this, right? So if you want to create this report, what is the total salary paid by the job? Can you tell me what is one? Which job is it? Manager. Okay. How do you know it is manager? Because in the designation table, we have the same one. One is what? Manager. That means you are looking up this one here, right? So this key one can go to this table using the same one and can fetch the corresponding, the designation name, right? If you are doing this kind of an activity in Excel, what is it we call? Vertical lookup, VLOOKUP, or index match, XLOOKUP, different formulas are there. But yeah, VLOOKUP. So you can do the VLOOKUP with this one in this table to fetch what is the job. We can easily do that, right? So the same thing in SQL is called a join. If you want to fetch the data from the other tables, what is it? It's a join, right? There are different types of joins, okay? In detailed discussion, we'll do it in SQL sessions. But understand that if the data is located in different tables, but there is a common key available, in Excel, we do a VLOOKUP to fetch the corresponding values. In SQL, we use joins. In Power BI, we use relationships. We'll also talk about that. In Power Query, we use merge. So Power Query and Power BI, we'll talk about that later. But for now, understand that in Excel, we use, it's a VLOOKUP. In SQL, we use join. Perfect. So when you have the data like this, you understand that in SQL, we need to use a join, right? So join syntax and all, that's a different thing. But tell me this, why do I need to, save the data like this instead of simply like this? I can directly store the job, which is manager, developer, tester, in the same table itself, right? Why do I need to convert them into numbers? And again, using those numbers, another table will help me to get what is the corresponding job value, okay? Why do we need to do this? Space. Yes, perfect. There is something called data redundancy. What is data redundancy? If the same value is repeated for multiple number of times, it is called redundant. The same value is getting repeated there. But the point is, you no need to write manager, 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 manager for multiple number of times. You simply assign a number to it or a key to it. Call one as manager. Okay. And you simply store this one. So what one, this particular one represents manager. Okay, this one is what? Manager. Okay, why do we do this? Why do we need to do this way? Because of the storage, the space, right? If you write manager, will definitely consume more space, more ink. If you take a pen and write it on the paper, you write manager and you write one. Which one consumes more ink? Definitely the word manager, because you will have to write a big word there. So when you assign a key to it, that key, one thing, it occupies very less space. And whenever you need it, you can fetch the data using a join or a VLOOKUP, right? So this process of splitting a table that has all the details in one table, splitting this table into multiple tables like this is called normalization. The technical definition sounds a little different, but understand that there is a big table that contains all the data. But what is it you do? You split the data into multiple small tables. Okay. As a result, you get the dimension tables and fact tables. What is normalization? You split the one table into multiple tables, right? So what kind of tables are derived there? Dimension tables and fact tables. Let's try to understand a dimension table and a fact table. Dimension table that holds categorical data. This is a dimension table. This is also a dimension table. So how do I say that, these things are dimension tables? Because these are dim tables. Only the categorical data. Something like location related details or, job related details or gender related details. So all these tables are basically dimension tables. They hold only categorical data. But there are fact tables also. Fact tables hold numerical data. So let me show you this. This is a fact table. So you should get a question. I have numerical data here also, right? I have the numbers there, right? But understand one thing, just because there are numbers, you cannot call every table as a fact table. Numerical data doesn't mean, IDs are not numerical data. I'll tell you why. What is numerical data and how to easily identify, very simple. You take a look at any table. In that entire table, at least one column allows you to do the sum of the column. You know the sum, right? At least one column allows you to do the sum of the column is a fact table. Remember this way. It's like very easy to remember. At least one column allows you to do the sum. So do I have any column that helps me to do the sum? Employee ID, you may be thinking, okay, this is a number. Can I do the sum of IDs? There is no point, right? Sum of student IDs, sum of employee IDs, it doesn't make sense. I can do a count of employee ID or I can do a count of student ID to know how many employees are there or how many students are there. But definitely not sum of IDs. IDs doesn't make sense, right? Can I do sum of salary? It makes sense, yes? Yes, sum of salary makes sense. So that means at least one column allows you to do the sum is factor. Got the one? Right. So this is a fact table. Of course, we also have the commission column. So commission is also numerical data. I can do the sum. Right. So take a look at the department. Tell me, is it possible to create each department wise what is the average salary paid? I want the department name and average salary. Can I achieve this output using this table only? Only this table? No, right? Why no? Because we don't have the department name in this. Okay, if you want to get the department name, what is it you do? Again, you need to do a lookup there or a join there, right? So where with the department ID to department table here. Similarly, if I want to find out what is the total salary paid by the gender, what is it I need to do? Same thing. Gender to gender ID here. Right. So the advantage of storing the data in multiple tables is you can significantly reduce the size or the space of, space that it occupies. Okay. So very, very useful data normalization. You assign only the keys and the corresponding key values will be available in some other table. It's very easy to fetch the data whenever you want. If it is Excel, we use the VLOOKUP. If it is SQL, we use joins, right? So I think you got some idea what is a join, right? Of course, we are not showing any syntax here, not needed at this point, okay? Because anyways, I load the data into Power BI and there you don't need to worry about a join syntax. We simply create a relationship. I'll show you how the relationships work. Okay. So here we go. Now you understand what is normalization. So the data is stored in multiple tables, not in a single table. The advantage of making something like this is because space, data redundancy and inconsistency issues can be reduced. Redundancy is nothing but the same values are repeated for multiple number of times. Instead of repeating the same physical value, what is that we repeat? We repeat only its code. The codes occupy lesser space than its physical value. Right? Is it fine? Now you got some idea? So tell me, if you are a reporting analyst, which type of data set you really like to work with? Denormalized or normalized? Denormalized or normalized? Denormalized is like this. and normalized is like this. As a data analyst or a reporting analyst, which data set would you prefer to work with? Which one? It's denormalized. You know why we prefer denormalized? Yeah, everything is one table, right? So if I want to get any kind of a question answered, I can use the same table because everything is present there. I no need to worry about looking up the value in some other table or doing a join with some other table. Everything is available in one table, so I can easily do that. But understand that in the real-time databases, the data is always normalized. Nothing but you find the data like this. Okay. In all the OLTPs, you find the data like this only. You don't directly see everything in one place. So if you want to create one report, you may need to join 5, 6 different tables also. Okay. But in OLTPs, it is usually highly normalized. In OLAP, it is a little normalized. I'll tell you why. OLAP is meant for what? Creating reports, dashboards, right? That data. So what these people do, the ETL developers do is they try to bring the data as close as possible. Okay. So the purpose of bringing the data as close as possible is because of this is meant for the reporting, right? More number of tables are involved, let's assume, more time it takes. The more number of joins you write, more time it takes to retrieve the data, right? But if the data is located in a few tables, then it is very easy for us to extract the data and create the reports. Simple. Let's say the required information is there with 20 team members. Okay. Team member A, team member B, team member C, and 20 team members are there, and each and everyone holds some important data. If you want to create a report, what is that you need to do? You need to talk to all 20 members, right? But what if each 5 members of your team reporting to one assistant manager? 5, 5, 5, 5. 20 members, right? 4 assistant managers are there. These people will collect those 5 members' data, right? So first assistant manager has 1 to 5 team members data. Second assistant manager has 6 to 10 team members data, and so on. 4. When you want to create a report, then you don't need to talk all 20 team members, right? You just need to talk with these 4 assistant managers to get the required amount of data. So that means if you can bring the data as close as possible, available in limited number of tables, then it is easy for you to create quick reports. But just in case if it is with so many tables and so many joins, if you write, definitely the report performance will be hampered. It will take more time to retrieve the data from different tables, right? So data normalization, yes, definitely needed. If it is OLTP, you see a lot of normalized tables. If it is OLAP, you see a little normalized tables. Okay, fine then. So I hope you understood the concept of normalization. So what is the benefit of normalization? You can efficiently, manage your memory, right? Reduce that size of those tables, and you can avoid the data redundancy, and you can reduce the data redundancy and inconsistency issues. That's why we do this data normalization. And as a result of normalization, the integrity constraints will be applied automatically. Let me show you what are there. So tell me, can I give a department ID 60 here? Why no? Perfect. So the department ID 60 is not available in this department's table. So as a result, you cannot use 60 because none of them here is a 60. Right? Data integrity. A department which is not there in the department's table cannot be assigned to any of the employee. It's as simple as that. If the department itself is not there in the department's table, how can you assign that department ID to the employee? You got the point, right? So department that is not there cannot be assigned to any employee. A simple example, uh, a student who is not there in the students table cannot take the exam. Make sense? An employee who is not there in the employee table cannot be there in the payroll table. Yes or no? It's as simple as that. So data integrity is possible with the help of normalization. If something is available, then only you can use it. If something is not available, you can't use it. Okay. So is this clear? Now, what is data normalization and data integrity? Once we do the data normalization, what type of tables do we see? Fact tables and dimension tables. Okay. So when we get into the data modeling, I'll talk about what is a star schema and what is a snowflake schema. I'll explain that later. But up to this point, if you are good with the data normalization and data integrity concepts, we are good to go. Are we good so far? Okay, perfect. So as a result of data normalization, we understand that fact tables and dimension tables are, derived. That's good. But if you want to create a report that consumes the data from both fact tables and dimension tables, like something like I want to create a report to show what is the total salary paid by the department name, right? Then what all tables are involved there? Employee table and departments table. Excellent. Employee table and department table. Now you tell me, if I want to bring the data together from two different tables, what is needed? A common key is needed. So tell me, between these two tables, employee table and department table, what is the common key? Department ID. Perfect. Department ID is the common key. This and this. Okay. So department ID is the common key, and using this only in Excel, we write the VLOOKUP, right? If I want to get the department here, we write that department. I want to get the DEPT there. DEPT name. So how do we do that? Equal to VLOOKUP. That common value, comma, table array. As soon as we select any table array, what is it we do? Freeze it. Second column and 0. That's it. That's how we can get the data from different tables into one place, right? Okay, cool then. Now here's the one. These keys in Excel, we call it a lookup value and table array and things like that, right? So these same keys in SQL, we use the words primary key and foreign key, right? Most of you would have heard these things. But let's try to understand what is a primary key and what is a foreign key. I'll tell you the definition today. Tomorrow I'll show you the exercises and I'll ask you different examples of primary key, foreign key. Okay. With that, you will get some clarity about how these tables can be connected together using these keys. Okay. Primary keys and foreign keys. Fine then. So the definition of a primary key is something that is unique and cannot be null. Okay. A key which is there in a table, a unique key to track every record of the table and which cannot be blank is a primary key. So in this example, if you look at this, each and every department has one ID. Yes, sir? So can the department ID be null like this? No way. If there is a department, that means there has to be a key to it. Okay. So what is a primary key? Primary key helps us to track each and every record with one unique identification number and which cannot be null, right? Here, the department ID is a primary key in the department table. The same department ID in the employee table is a foreign key. Why? Because multiple employees will be working under one department. So that's the reason if you observe here, this employee working in department 10, 10. You see that all these employees are working in 10 only. What is department 10? HRD, right? So the same primary key can be repeated for multiple number of times. If you do that, you can call it foreign key. So what is a foreign key? A foreign key is a primary key of some other table. Make sense, right? What is a primary key? A primary key helps us to track each and every record uniquely, and a primary key cannot be null. Okay, so primary key properties are, one thing, it must be unique, and the second one is it can't be null. What is a foreign key? The same primary key acts as a foreign key in some other table to maintain the data integrity. Okay, so if the department 60 is not there in the primary key table, you cannot assign the 60 here. Is it fine? Right. So now you understand what is a primary key and what is a foreign key. Perfect. Job ID. Which type of key here it is? It's a, okay, how do you know it's foreign key? Right, the same job ID is there in the designation table, right? Okay, now tell me which type of a key is it? Right, it's a primary key, right? And the same primary key acts as a foreign key in some other table. So it's a foreign key. Okay. Gender ID in this table, which type of a key is it? It's a primary key because each and every gender got one key there. And the same gender ID in the employee table, foreign key. This is very much important to understand a primary key and a foreign key to build the data models in Power BI. Okay, to build the data models in Power BI. Right then. So tell me this, primary key, how many times it exists there? Each key? Each key only once. The same primary key as a foreign key, how many times it can exist there? Multiple times. So we also talk about the relationship cardinality. There I talk about what is one to many, many to one, one to one, many to many. Okay. So we'll talk about that also. But for now, you understood, right? How these keys look. Okay. But by the way, why the keys are coming into picture? Because of why we got these keys. Because of data normalization. Okay. Why did we perform the data normalization? To reduce the data redundancy and inconsistency issues, right? That's the purpose we did data normalization, right? Once you perform the data normalization, what type of tables will be derived? Fact tables and dimension tables. Okay, dimension tables hold what? Categorical data. Fact tables hold what? Numerical data. How to say something is a fact table? Fact table. It has at least one column that can be calculated, nothing but if you can do the sum of that column, then yes, you can consider that as a fact table. And in the categorical data, in the dimension table, you can't find any columns that can be summed up. Okay. Fine then. So if you are good with this, then you should be able to proceed to the next one. Okay, let me just show you this. Now let's talk about normalization. OLTP databases are normalized, at least up to third normal form, okay? A few of the articles, they show 1 to 5 normal forms. There are a few of the articles, they say 1 to 4 normal forms. Depends, there are different articles there. So third normal form. So different rules are there, but someone who develops the databases, they need to, do that third normal form. But yes, our understanding is OLTP databases are normalized. The tables in OLAP are not normalized. There will be a little normalization, but the point is not very much normalized. Okay. Because in OLAP, what these ETL developers do, they try to bring the data as close as possible. they don't keep so many tables. Okay. So many number of tables are there, then definitely the query speed will be slowed down. So that's the reason a lot of normalization is not usually done in the OLAP. And coming to the integrity, OLTP database must maintain the data integrity. See, the thing is, I showed you one example. If the department ID is not there in the department's table, you cannot use the same, that department ID in the employee table if it is not present in the department's table. So because it is normalized, so it must maintain the data integrity constant. OLAP database doesn't get frequently modified, hence the data integrity is not affected. And I'll tell you one more interesting thing. The OLAP database gets the data from where? OLAP gets the data from where? OLTP only, right? See, the thing is, if the data has a integrity already at OLTP level, the same data will be loaded into your OLAP, right? Then the data integrity is always maintained. If the OLTP is maintaining it, automatically the same thing will come into OLAP, right? OLTP maintains the data integrity, so the same thing will come into OLAP. So absolutely no issue there. So you understood what is normalization, you understood what is integrity, right? So these are the things we definitely need to understand before we get into Power BI, right? There is one more topic, especially about the primary key, foreign key, how to identify them. So I'll show you an example of a simple data model tomorrow, right, in Power BI. Then you will understand how these keys, primary keys, foreign keys are playing their roles there, okay? But up to this point, everyone is okay with this? Understood the concepts of SQL, OLTP, OLAP, right? Queries, I'll show you a few simple queries tomorrow, okay? But we write those queries in Power BI environment. Usually SQL people, you use the client application, which is SSMS. SQL Server people, they use the SSMS, SQL Server Management Studio, but we can use Power BI application also as a client only. Okay, it's fine then. Any questions up to this? Yeah, perfect then. Cool. So let's catch up tomorrow. Please come around 7:45 only. So for the next few days, right? And then I'll let you know when we can switch back to 7:30. Done then. So please make sure you just go through this video once again if needed. Open this material and try to remember these points, right? And tomorrow we'll see the keys, how to use them, writing simple SQL queries inside Power BI. I'll show you. Okay. Cool then. Any questions? Great then. So I hope all of you got the material in the Google Drive. Yes. Okay, fine then. Thanks everyone then. I'll see you. Bye.